Right, in this video we're going to look at dividing fractions. Now before we do that, I want to talk to you about a word we're going to be using quite often, and it's called the reciprocal. So what the reciprocal is, it's also known as the multiplicative inverse. And really what the reciprocal is it's basically taking your fraction and flipping it upside down. So the denominator and the numerator are going to switch spots, okay? So this is what we call the reciprocal, okay? So the denominator and the numerator switch spots, okay? So here's what it would look like. If I had the fraction 7 over 8 and I wanted to find the reciprocal of this fraction, the reciprocal is really just going to take my 7 from the numerator and move it to the denominator, and take the 8 from the denominator and move it up to the numerator. It's kind of like the fraction flips around and does a handstand. So what was on top moves down and what was down moves up. So the reciprocal would become 8 over 7. Okay? So reciprocal is actually really easy to do. You can really do it with any fraction, right? The reciprocal of 3 over 5, I would just simply make the numerator and denominator switch spots. So we make them flip, and the 5 moves up top and the 3 moves down below. Now, I could also give you something that is a mixed number. So if I gave you 1 and 3 over 7, I'm not allowed to make my numerator and denominator flip just yet, because I still have that 1 in front. So before I find the reciprocal of a mixed number, I need to make sure that I've gone and changed it to an improper fraction. So I take the whole number 1, multiply by the denominator of 7, add the 3, and the denominator still stays as a 7. So 1 times 7 is 7, plus 3 is 10. So another way of writing 1 and 3 over 7 is 10 over 7. And when I go to find the reciprocal of 10 over 7, my values in numerator denominator switch spots, and the reciprocal would change it to 7 over 10. Now notice when I did it, I never said that they were equal. I used an arrow to say I was finding the reciprocal, so they are not equal to one another. Okay, it's the flip of one of them. Now it's called the multiplicative inverse, and the reason it's called the multiplicative inverse is if I was to take my 7 over 8 and I found my reciprocal, which we said was 8 over 7. Okay, they switch spots. When I multiply those two fractions together, so when I multiply 7 over 8 and its reciprocal, 8 over 7, I get some nice cross-reducing that I can do here, because 8 and 8 are both divisible by 8, so that gives me 1 and 1. 7 and 7 also happen to both be divisible by 7. 7 divided by 7 is 1 in the numerator and denominator. And I get 1 times 1 over 1 times 1, which is just 1 over 1, which is 1. It's called the multiplicative inverse because it means when you multiply by the reciprocal, you should get 1. So any fraction times the reciprocal of itself gives you 1. And that's what we refer to as the multiplicative inverse. So what we looked at before in our previous video was how to divide by whole numbers using diagrams. And I hope that what you noticed when you were doing those diagrams is when I was writing 1 over 2 divided by 4, what really happened was the denominator and that divisor of 4, those guys ended up multiplying together. So this would give me the same thing as 1 over 8. And if you want to draw the diagram out to test it, go ahead. Now I want to point something else out to you that's kind of interesting. If I took 1 over 2 and I multiplied by the reciprocal of 4, which just happens to be 1 over 4, okay, because any whole number is the same thing as 4 over 1, okay? I didn't write the over 1, but that's the same thing going on there. This would be 1 times 1 and 2 times 4, and that gives me 1 over 8. These guys say the exact same thing. And that's actually the process that I'm going to use for dividing fractions, is I'm instead going to change to multiplying. And it makes my life so much simpler, okay? So if I was to go 7 over 8, divided by 1 over 4. Okay, what I'm going to do is I don't want to divide. I would way rather multiply, because we said multiplying was so much easier than adding, subtracting. So what I would rather do is, instead of dividing, I would like to change that dividing to a multiplication. So I'm going to change it to a multiplication. Now, dividing and multiplying, they are different things, right? So if I'm going to change that division to a multiplication, what I need to do is I need to take my multiplicative inverse, or I need to take my reciprocal of that second fraction, or my divisor. So I'm going to flip this 1 over 4, and I'm going to flip it upside down and write it as 4 over 1. Okay? 7 over 8 times 4 over 1 is the exact same thing as 7 over 8 divided by 1/4. So 7 over 8 times 4 over 1 will give you the exact same answer as the other. Okay? Okay, so looking at this one, 7 over 8 times 4 over 1. I have to put this one, do my cross reducing. So 8 divided by 4, that gives me 2. And 4 divided by 4 gives me 1. And so now I have 7 times 1 for my numerator and 2 times 1 for the denominator, and that gives me 7 over 2. Now again, I do want you to take answers and change them from improper back into mixed. So I know 2 can fit into 7 3 full times, and that took up 6 pieces, so there's a remainder of 1. So it's the same thing as 3 and 1/2. Okay, let's do another one here. What if I had 9 over 16 divided by 3 over 8? Okay, so again, I don't want to do any dividing. I'm going to leave that first fraction as it is. I'm totally fine with that one. But instead of dividing, I want to multiply, because multiplying is so easy. If I'm going to change from dividing to multiplying, I have to find the reciprocal of my second fraction. So I'm going to write it as 8 over 3. And now I'm multiplying, and we're going to cross reduce. 9 and 3 both have a common factor of 3. So 9 divided by 3 is 3, and 3 divided by 3 is 1. 8 and 16 have a common factor of 8. 8 divided by 8 is 1. 16 divided by 8 is 2. And now I'm left with 3 times 1 for my numerator and 2 times 1 for the denominator, and that's 3 over 2. I know that 2 can go into 3 one full time, and then I have a remainder of 1. So I have 1 and 1/2. Okay? So what we are doing each time is, my steps for dividing really would be, don't divide. Okay? Don't divide. Multiply by the reciprocal instead. Okay? And that's really our rules for dividing. Don't divide, multiply by the reciprocal instead. Okay, so let's do another one. We'll see how fast we can go. 7 over 15 divided by 14 over 3. So now would be a good time for you to pause the video, time yourself, see if you can do this one, okay? So remember, don't divide, multiply by the reciprocal. All right, now that you've unpaused it, you want to see how this goes? And if you didn't, then I just sound like an idiot. Thanks for that. Change the division to a multiplication, okay? Instead of dividing, multiply. Then, instead of this second fraction, I have to change it to its reciprocal. So it's going to be 3 over 14. Now I'm going to cross reduce. 15 and 3 have a common factor of 3. 3 divided by 3 is 1. 15 divided by 3 is 5. 7 and 14 have common factor of 7. 7 divided by 7 is 1. 14 divided by 7 is 2. 1 times 1 is 1. 5 times 2 gives me 10. So I get 1 over 10 as my answer. Last one. What if I had 1 over 12 divided by 3/4? Okay, same thing. And actually pause it this time for those of you who didn't. You cheaters. Pause it. Time yourself. And again, if you didn't pause it, you're making me sound like a real idiot, because I just have this natural pause that doesn't make any sense to you. Okay, so I got 1 over 12. Instead of dividing, change it to multiplying. Second fraction, flip it upside down, find its reciprocal. That gives me 4 over 3. Cross reduce. 1 and 3, no common factors. 12 and 4, common factor 4. 4 divided by 4 is 1. 12 divided by 4 is 3. And that gives us 1 times 1, which is 1. 3 times 3, which is 9. Okay, so that's dividing fractions. And the funny thing is, we don't actually divide. We multiply by the reciprocal.